Welcome back, folks, to another lecture. This is the continuation of section 3.2. We'll be talking about a specific procedure to find absolute extreme values of a function. What do we mean by extrema or extrema is actually the local max min points on a curve. That's what we call it extrema. Extrema could be maximum, could be minimum. The procedure is very clear. I already wrote the 4 steps here. So let me tell you what is given. Some sort of function is given. In this case, is a cubic function. And some sort of interval is also given with the 2 endpoints, -5 and 3 inclusive. That's what is given normally. What do we want to do? We want to find the absolute maximum value and absolute minimum value of this function over that interval from -5 to 3. What should we do? Number 1, we find all the critical numbers within that given interval, closed interval from a to b of f of x by setting f prime of x equal to 0. So we talked about this in the past lecture. We defined what critical numbers were, and I hope you have checked that video before you actually watch this one. So we're going to find the critical numbers of the function, and then we're going to find the value of the function at those critical numbers. Maybe one function has only one critical number. Maybe it has 2 or 3 critical numbers. It doesn't matter. If they have like even 4 critical numbers, we're going to find the value of f at all of those 4 critical numbers. And then we're going to find the value of f at the 2 endpoints. One endpoint was a, one endpoint was b. In this example, I'm going to work out shortly. A and B are -5 and 3 actually. And then the last step is just comparing and selecting the largest value and the smallest value among f of c, f of a, and f of b. And then we're going to announce it as the absolute maximum value and absolute minimum value of the function. So let's start by following the procedure. A function is given over a restricted interval. It says find all critical numbers, so I'm going to take the derivative of the function. That's a cubic function, so 3x squared minus 12, that is the first derivative. And to find the critical numbers, in the past lecture, I told you we have to set y prime equal to 0. And that's what I'm going to do right now. F prime of x equals 0. So I get 3x squared minus 12 equals 0, from where 3x squared will be 12. And that means x squared is 4, and taking the square root of both sides, we end up with plus minus 2. So apparently this function has 2 critical numbers. One is -2, one is +2. So I can just call these, for example, c sub 1 and c sub 2. The first and second critical numbers. One is +2, one is -2. All right, I'm done with step 1. You can also do this for your homework questions. Step 2, it says find f at c. We find the value of the function at each critical number. So I'm going to list them here actually. I'm going to find f at c1, which is f at 2. And also I'm going to find f at c2 because in my function I had like 2 critical numbers. Sometimes you have only 1, sometimes you have more than 2. In my case, I have 2 critical numbers, so I'm going to find f at those 2 values, and that's not hard to do. I'm going to plug in 2 for x in the equation of f of x. One of the common mistakes right away I tell you students make is that instead of plugging in the original function f of x, by mistake, they plug in f prime equation, and they plug in 2 for x in the equation of f prime instead of f. Don't make that mistake, all right? So now we end up with 8 minus 24 plus 23. That is a 7. I found a value. For this one, -2, I plug it in the original function. I'm not going to make that mistake. So this is going to be 24, 23. That is 40, how much? 24, 23, that's 47. 47 and minus 8, that would be 39. There you go. So I found f at c, which is step 2 of the procedure. At each critical number, we found the value of f. Step 3, it says find f at a, f at b. Well, this is so simple. They give you the a and b values. Here, this is your a value, and this is your b value. It is given to you in the question. You don't need to worry about it. So you're going to go f at A, which in this case would be f at -5, f at B, which is f at 3 in this case. And now I plug in and I end up with -42, making a long story short. I plug in 3, I do 14 here, and that is the end of step 3. As you see, it's very, very simple and easy to follow procedure. So I have 4 values here right now. 2 of them are the values of the function at the endpoints, A and B. The other 2 are the values of the function f at their critical numbers. So what I'm supposed to do now is just compare. All I have to do is to compare and select the largest and the smallest among these 4 values I got. And then we're going to announce it as the maximum, absolute max value, absolute mean value. Now you tell me, I say nothing, you tell me, among 14, -42, 39, and 7, which value is the largest? Whatever you say, I accept. You said 39. I bet you did. So 39 is going to be the absolute maximum value of this function. And now you tell me what value among these 4 values is the smallest. I bet again you're going to say -42. So that is my absolute minimum value of the function. All right. We were supposed to find absolute extrema values, and we actually did, okay, with each other's help. 7 and 49, we don't care. Now, if you look at the brief sketch of this cubic function, you see that point A at -5, -42 is the endpoint, which happens to be the point with the lowest y value, actually. And then we have this point B with the highest y value. So that will be our absolute maximum value, 39, absolute maximum point. That's point B. And then we have point C, which is just a local minimum point. Its y coordinate was only 7. It was like among the other 4 values, not important. And the last endpoint on the right-hand side has a y coordinate of 14, which is, of course, not more than 39. So that is just a regular endpoint. So one endpoint on the left, which happens to be the absolute minimum point, one point in the middle, absolute maximum point, which happens to be a local maximum point as well. Point C, it's a local minimum point, and point D is just a simple endpoint. All right. So final answer to the question. We're going to say absolute maximum value of f of x over the closed interval of -5, 3, the given interval, is, how much was the absolute max? It was 39, so I'm going to write 39. Achieved at x equals, how much was that? -2, which was one of the critical numbers, if you recall. And then absolute minimum value of x over -5, 3 interval is, what was that? -42, achieved at x equals -5, which was one of the endpoints. So this exercise tells us that it is possible to have an absolute minimum point, which happens to be an endpoint. So not necessarily absolute maximum, absolute minimum points are supposed to be local maximum and minimum points. Not necessarily. This exercise clearly showed to us that one endpoint, endpoint A, happened to be the absolute minimum point. And of course, point B not only was a local maximum point, but also it happens to be the absolute maximum point in this exercise. I hope this exercise, was helpful. I have some homework questions for you that I'm going to post very soon.